Hello friends, welcome to Risingpearl.com. Today we are talking about series 2 where we are learning a great deal on triangles. Friends, today is webisode number 25 and today we are going to look at solving problems related to Pythagoras theorem. So friends, let's get started. Now we will very briefly talk about what is our overall strategy. How are we going to approach these questions? So the first thing is we are going to look at the terms which are in the final equation. So what do we mean by the terms? And we will solve many questions in this webisode. But right now let's try and understand that these kind of questions will ask you to prove that something equals to something, right? So those are what we are referring to as the terms in the final equation. So first we are going to be on a lookout for what are the terms in the final equation that we need to prove. Second, we are going to we will find out which right angled triangles contain those terms. So whatever the terms that we actually need in the final equation, which right triangles contain those terms. We are going to identify what are the right triangles or right angled triangles. In short, I'm writing it as right triangles. Which right angled triangles contain those terms? And finally, the step 3 is start with those right triangles and apply Pythagoras theorem. So friends, this is like a step 1. Identify the terms, look at the terms which are in the final equation that we need to prove. Step 2, find out which right angled triangles contain those terms. And step 3 is start with those right angled triangles as you identify from step 2 and apply Pythagoras theorem for those right angled triangles. Now with this said, friends, let's take a look at our first example, first question. In the figure below, ABC is a right angled triangle such that angle B is 90 degrees. So we have a right angle triangle ABC. It is given that angle B is 90 degrees. 90 degrees. Also BX is perpendicular to AC. So this line BX is actually perpendicular to AC. This is what is given. Now we need to prove AB squared plus CX squared is equal to BC squared plus AX squared. So friends, this is what I was referring to as terms. So this is a term, this is a term, this is a term, this is a term. So this is our final equation we need to prove. So how are we going to get started with this type of question? Well, the first thing is we are going to focus on triangle AXC or BCX. Why? Because if you look at which terms we need AB squared, this is AB squared, CX squared, this is CX squared, BC squared, this is BC squared, AX squared, this is AX squared. So if I look at BC squared and CX squared, they are the terms which is in this triangle, right angle triangle, which is highlighted in blue, right? So we are going to apply Pythagoras theorem on this triangle BCX. BCX is a right angle triangle because this angle is 90 degrees, it is given. So applying the Pythagoras theorem, what do we get? We get BC square is equal to, BC is the hypotenuse, side opposite to the 90 degree angle, is equal to BX square plus CX square. CX square, right? BC square is equal to BX square plus CX square. Next, friends, we are going to take a look at this right angle triangle which is highlighted in blue now. Why? Because this right angle triangle contains AB square and AX square. So this angle is 90 degrees, right? Because BX is perpendicular to AC. So this is a hypotenuse. Angle opposite to the 90 degrees is hypotenuse. So in right angle triangle ABX, AB square, let's write it this way, AB square is equal to BX square plus AX square. AX square. So friends, if we call this one as our first equation and we call this one as our second equation, if you notice here, this equation contains the two terms we need, BC square and CX square. BX square we don't need. In the second equation, we have AB square which we need and AX square we need, but BX square we don't need. So what we can do is, from equation 1, we can write BX square in terms of the other two terms, and then we can replace BX square in our equation 2 by what we get from equation 1. So let's write it down. So from equation 1, we get BX square is equal to, we will move the CX square on the other side of the equality sign, and so plus will become minus. So we will get BC square minus CX square. Let us call this equation 3. And now we will replace BX square in equation 2 with this value. So what we will get, friends, is this. We will have AB square, I'm writing equation 2, AB square is equal to, instead of writing BX square, I want to replace BX square by this value. So I'm going to write BC square minus CX square and then plus AX square. So here, friends, what we will do is, we will just simply take this CX square term, it is minus, we will just take it on this side of the equality sign, so it will become plus. So what we will have is AB square minus will become plus, CX square is equal to, on the right hand side we will have BC square plus AX square. So friends, if you look at what we have to prove, AB square plus CX square, we have AB square plus CX square equal to BC square plus AX square. That is exactly what we have, BC square plus AX square. So friends, as you can see how we use those three steps as a guiding principle or just as a reference point for us to think through, and that helped us solve this question. Let's apply the same concept or those same that same approach to some more questions. Here, friends, we are looking at question number 2. Here in the figure below, triangle ABC is right angled at B. So we have a right angle triangle ABC, and this angle is 90 degrees. AX and CY are medians of side BC and AB. So AX is a median to side BC. It means if you look at the side BC, X is the midpoint. So median is nothing but, if you look at the midpoint of a side and if you join that point to the other vertex, so that line is your median. So AX is the median. That means this length is equal to this length. That is, X is the midpoint. Similarly, CY is the median for AB. So CY is a median for AB. That means Y is the midpoint of AB. So these two lengths are equal. So what do we have to prove here? We have to prove that 4 times AX square plus CY square, which is AX square, this is AX, 4 times this, which is the median, plus CY square, which is the median, is equal to 5 times AC square. This is what we have to prove. So friends, how are we going to approach this? So again our focus is, let's look at the terms. So ax square, cy square and ac square. So ax square, which triangle has ax? Which right triangle has ax? Yes, this triangle highlighted in blue has ax. So if you look at triangle ABX, angle B is 90 degrees. So ax is the hypotenuse. So what we can write is ax square is equal to AB square plus BX square. BX square. Let us say this is our equation 1. Now similarly, how can we get cy square? Cy is this line, cy, which is the other median. So as you can imagine, now we are going to focus on this triangle highlighted in blue. Cy, if you look at triangle BCY, it's right angled at angle B. So this is the right angle triangle. So cy is the hypotenuse. So we can write cy square is equal to by square plus bc square. So this is our equation number 2. Now friends, look at what we have to do. We have to prove ax square plus bx square is equal to something. So we will simply add equation 1 and equation 2. That is, we are going to just add these two equations. So what happens when you add these two equations? Let's give ourselves some more space. So what will happen is, let's write from here. On the left hand side you will have ax square plus cy square. So we will have ax square plus cy square, right? Equal to, on the right hand side you will have these four terms, ab square plus bx square plus by square plus bc square. Let's write them down. So we have ab square plus bx square plus by square plus bc square. So we have simply added the two equations. So when you add two equations, so you have to add the left hand side separately equal to the right hand side, right? So just think about it this way, right? If you have the number 5 written as 2 plus 3 and you have 8 written as, say, 2 plus 6. So if you add them, you have to add this, which will be 13, which will be equal to 2 plus 3 plus 2 plus 6, right? So which is like 4, 2 plus 2 4 plus 6 10 plus 3 13. So simply if you add an equation, so you have to add the terms on the left side, so which is what we have done here, equal to, you have to add all the terms on the right side. Now friends, here if you look at bx, which is this length bx, because x is a midpoint, we can express bx as half of bc, right? Because x is a midpoint, so bx, let's write it here. So what we know is we can actually write bx is half of bc, right? Bx is half of bc. Similarly, by is half of ab. By is half of ab because x is a median and y is a median. So in this equation over here we have ab square plus, instead of bx we can write half bc, so we will have bc by 2, and that square, remember it is bx square, plus we have by, instead of by we can write ab by 2, AB by 2 square plus BC square plus BC square. Or if you try to solve it, what you will have is, so here you will have AB square. So this is a AB square term, this is a AB square term. So if you take the bracket out, so you will get AB square plus, let's write AB square by 4. So it will be AB square divided by 2 square. 2 square is 4. So you will get AB square by 4 plus you have BC square by 4 here. BC square by 4, which is this term, plus BC square plus BC square. So now here, friends, we have essentially AB square and AB square by 4. If you calculate this and this terms together, and if you calculate this and this term together, because they are like terms, AB square plus AB square by 4. So if you take LCM, you will have 4, and then you will have 4AB square plus 1AB square. You will get 5AB square. 5AB square plus, similarly here you will get 5 by 4 BC square, or 5 BC square by 4. So friends, here what we have is, from these two you can, let's write it here. So we have AX, on my left hand side we still have this AX square plus CY square is equal to, if I take 5 by 4 common, I get AB square plus BC square. AB square plus BC square. Yeah, we should have given us a little bit more space. So which is equal to, now what is AB square plus BC square? If you look at this triangle, triangle ABC, the whole triangle, the big triangle ABC, AB square plus BC square is nothing but AC square, right? Because triangle ABC is a right angle triangle, right angled at B. So AC is the hypotenuse, right? So we get 5 by 4 AC square. So now friends, what we have is, we have on the left hand side we have this, right, AX square plus CY square, and on the right hand side we have 5 by 4 AC square. So we can multiply both sides by 4. So what will we get? We will get 4 times AX square plus CY square, AX square plus CY square is equal to, on the right side we have 5 AC square. 5 AC square. So friends, which is exactly what we have to prove. 4 times AX square plus CY square is equal to 5 times AC square, and this is what we have proved. 4 times AX square plus CY square is equal to 5 times AC square. So friends, again in this question we went with those 3 simple concepts. Identify the terms which are in the final equation. Second, look for the right angle triangles that contain those terms. And third step, apply Pythagoras theorem for those right angle triangles. So that framework still helped us solve this question. Now let's take a look at maybe one final question before we wrap up this presentation. So what we are given, friends, is MN are points on sides RP and RQ respectively of a triangle PQR right angled at R. So we have not been given any shape, so we have to draw our own shape here. So let us first draw a right angle triangle. So we have drawn a right angle triangle PRQ, right, or PQR, such that it is right angled at R. So our triangle is right angled here at R, and M and N are any 2 points. We have not been given really much information about M and N. M and N are 2 points on side RP. RP is M, RQ is N. Because nothing else is given, you can really pick these 2 points wherever you want. You could have picked M here and N over there, or you could have picked both wherever you like, right? So I have randomly picked 2 points, M and N. And friends, like I have mentioned earlier, if we have to do our construction, right, if the shape is not given to us, we want to make sure that we do not draw any specialized shape. That is, I do not want to pick M as a midpoint of PR, and I do not want to pick N as a midpoint of RQ. So I'm randomly picking M somewhere, and I'm randomly picking the point N somewhere on RQ. Now what we have to do is, we have to prove Pn square. So what is Pn square? So Pn square will be this, right? So we have to then join P and N. Let's do that. Because we have Pn square, so we joined Pn plus Qm square. So Qm is this line, so we have to join Qm as well. So we have Qm square, and then we have is equal to PQ square, which is PQ square, plus Mn square. So looks like Mn would be this line. So we have to do one final thing, which is we have to join Mn as well. So friends, now going back to our approach, so what we will do, so since we have to apply Pn square, so and Pn square is available in this right angle triangle PRN. Remember that this is 90 degrees. So PRN is a right angle triangle. So what is Pn square? So I have Pn square, hypotenuse, from Pythagoras theorem we get, it is PR square plus Rn square. Rn square. This is, we call it our equation number 1, first equation. Now similarly friends, what we have from the second term is Qm square. So Qm is in this triangle highlighted in blue. This is again 90 degrees. So in right angle triangle MRQ, Qm is the hypotenuse. Pythagoras theorem, Qm square is equal to Mr square, Mr square plus RQ square, RQ square. Let's call this equation number 2. So now friends, if you notice, we have Pn square and Mq square, right? So then what we can say is, how about if we were to add equation 1 and equation 2? So let's do it. So let's quickly write. So we had, let's see, equation 1 was Pn square equal to PR square plus Rn square, right? And this is our equation 2. So let's just write equation 1 here for our easy reference. PR square, actually Pn square, it should be Pn square, the hypotenuse is Pn. Pn square is equal to PR square plus Rn square. Rn square. This was our, we just rewrote our equation 1. Now we want to add equation 1 and 2. So we have to add the left hand side terms together. That will be equal to the right hand side terms together. So on the left hand side we will have, let's write it here, Pn square plus Qm square equal to, on the right side we will have Mr square, Mr square plus RQ square plus PR square plus Rn square. So I have 4 terms on the right hand side. Let's continue to simplify this. So we have got our left hand side Pn square plus Qm square, because we have Pn square plus Qm square. Now let's figure out this. So here if you look at Mr square, what is Mr? Mr square plus Rn square. If I take this term Mr square and Rn square, if I take these two terms together, I'm just trying to rearrange this. So my left hand side is this. Let's just give ourselves a little bit more space. Pn square is my left hand side plus Qm square, and now I want to write, I'm just rearranging the terms. So Mr square plus Rn square. And why am I doing this, friends? Because Mr square and Rn square, they are part of the right angle triangle MNR, right? Mr square and Rn square, they are part of right angle triangle MNR. So I want to write them together, these two signs. Then plus I am left with the other two terms, which is RQ square plus then PR square. So here, friends, this, if you look at, like we just talked about, the right angle triangle MNR, now Mr square plus Rn square is nothing but it is equal to Mn square, because Mn is the hypotenuse, right? So this will give us Mn square plus similarly RQ square plus PR square is nothing but PQ square. Why? If you take a look at the whole triangle PQR, that is right angled at angle R. So PQ is the hypotenuse. So PR square plus RQ square is nothing but it is equal to PQ square. So this will give us PQ square. So friends, if you look at it, we started off with this, right? Pn square plus Qm square, Pm square plus Qm square, and we found out this is equal to PQ square plus Mn square. Hence, friends, we can say that we have proved the equality. So friends, again, like you saw, whenever we have these kind of questions, our goal really is to think through in this fashion. We look at the terms which are in the final equation we have to prove. Then we find out which right angle triangles contain those terms. And then finally we start with applying Pythagoras theorems for those right angle triangles and see where we go from there. So friends, I hope that you are following us along at risingpearl.com for all these webisodes, and that this at least gives you some structure of how to solve these kinds of questions. In the next video, friends, we are going to take a look at some more examples of questions on Pythagoras theorem.